rational exponents. So remember, this isn't radical exponents, although this is the radical chapter. These are rational exponents. So remember, rational numbers are fractions or integers, those types of things. So I'm going to write down, let's see, I'm going to do base A. Let's raise that to the m over n power. So there's a fractional exponent, right? So it's rational. So I'm going to tell you what that's equivalent to. So this number here in the denominator, which is n, is actually going to be the index of the radical, and the m is going to remain the exponent on the base. So when we have a to the m over n, that's really the nth root of a to the m. And there's also one other way we can think about this, and that is just taking the nth root of a and then raising all of that to the mth power. So let's do an example. What if I had x to the 1/2 power? So according to our rule up here, the denominator, which in this case is 2, is telling us the index. So that would mean we're doing a square root, and we're doing x to the 1st power, which is just x. So x to the 1/2 is really just the square root of x. So x to the 1/3, that would be the cube root of x, and so on. So let's see why these rational exponents are so nice to work with. Let's do a problem with a little multiplication. How about x to the 3 over 2 times x to the 1 over 2. So according to rules of exponents, when we're multiplying expressions with a common base, in this case x, we can add the exponents. So let's see, 3/2 plus 1/2 would be 4/2, which would simplify to 2. So the answer to this would be x squared. Now that was really easy, working with these fractional exponents compared to if they were in their radical form. Let me just compare that to their radical form. So x to the 3/2 would really be the square root of x cubed, and this x to the 1/2 is really the square root of x. So if you were to multiply those, right, you'd get the square root of x to the 4th, which would then lead back to x squared. So it took a little bit more work and thinking to get to the same answer. So these fractional exponents are a lot easier to work with. Let me just remind you of one other nice trick with exponents. What if I had 1 over x to the -1 power? Okay, usually when we see that negative exponent, it's on something like an integer, and you would want to make that into a fraction. But in this case, it already is a fraction. So if that's the case, just remember that you can take the reciprocal of the fraction and make the exponent positive. So this would really just be x. So that's going to be helpful when I give you this next question. Let's simplify 9 over 25 to the -1/2 power. So I just gave you this little reminder about negative exponents. So here we have a negative exponent that already is a fraction, so I'm going to take its reciprocal, so it's 25 over 9, and I'm going to make that exponent positive. So now it's to the 1/2 power. And now 1/2 power means to square root. So I should be taking the square root of 25 and put that over the square root of 9. Oh, and I can simplify those into 5 over 3. Okay, so it's time to try some practice for rational exponents.